All right, welcome. Let's open up our new unit talking about two things that are very, very, very prevalent in our lives, and that is metals and nonmetals. If you look on the periodic table, you'll notice that majority of elements on the periodic table are indeed metals, and that's all the ones in the red right here, which is basically the left side of the periodic table. You're familiar with metals. You've heard of iron before, copper, sodium, titanium, which is the popular thing for men now to get when they wear their wedding rings. You've heard of things like gold and silver. So metals are something we're familiar with in our everyday lives. Now, metals have certain specific properties to them that are different than nonmetals. First of all, they conduct heat and electricity. That's why when you cook, you use a metal pot or pan. Obviously, through conduction, the heat touches the pot and then transfers that heat to the food to cook it. But also for electricity, we know the majority of the things we plug in inside that plug or that wire is actually copper wiring, which is going to conduct electricity and allow us to use different things like computers, charging our phones, etc. But also, not only is it a good conductor of electricity and heat, but also you can stretch metal. So like copper wire right here was stretched in something called a die to make long, thin strands so that we can use it for wire and actually twist it and shape it into some type of copper twine, if you will. The beautiful thing about metals as well is that they're malleable. Malleable means that they're bendable without breaking. Think of a paper clip. The idea here is that you can bend it and shape it on the paper, right? So that it stays there, but it doesn't actually break. And that makes sense because all of the plugs and things we plug into the wall with copper wire can bend in that and wrap around so that they actually can, not break, but still allow us to plug into the wall. The other property is that metals tend to have luster. Luster means that they're shiny. So as we watched in a video a little while ago, the shininess of metal was something that gave it value. We thought it was pretty. For example, gold is a very decorative metal because of its shiny luster and color. It's pretty. But also, majority of the metals at room temperature are solid on this planet. The only exception is good old quicksilver, which is mercury. Mercury is actually a liquid at room temperature. It's the only metal, though, that is liquid at room temperature. Otherwise, most are solid. Now, nonmetals, on the other hand, have different properties from metals. In fact, the right side of the periodic table is nonmetals, and then our one lone element over there, good old hydrogen, is by itself as a nonmetal. But most of them to the right are nonmetals. Things you've heard of before, like chlorine, carbon, iodine, and oxygen, are all nonmetals. But let's look at their properties to see what actually defines them. A big property of nonmetals tend to be opposite of metals. So instead of having luster, they tend to be dull in color and not very shiny. And instead of metals being good conductors of heat and electricity, nonmetals tend to be poor conductors of that. So in fact, instead of conductors, we call nonmetals often insulators. And insulators are good because they don't conduct heat or electricity, allowing us not to be electrocuted, or also not to let something lose heat or gain heat. So think of an insulator as like a cooler for keeping water bottles cold. Or an insulator for electricity would be the wire being coated by rubber so that you can plug an object into the wall and not get electrocuted. Another property of nonmetals is that they're brittle, meaning when you put them between your fingers, you crush them or that, they crumble instead of bend and shift like metals would. And a lot of nonmetals are actually gas at room temperature. These are a couple of examples of nonmetals that are not gas at room temperature. This is the element sulfur. Sulfur has a natural yellow color. This is the element carbon. And we know carbon is black. One of the types of carbons out there is graphite for like your pencil. And then this solid is actually iodine. And iodine is a solid that turns quickly into a vapor or a gas. All right, but definitely they follow all of these traits, and they're very different than metals. All right, there's another group then that are caught in between, and that is called the metalloids. The metalloids have properties that are different or in between both metals and nonmetals. Sometimes we call the metalloids straight up semi-metals because they're not completely metal and they're not completely non-metal. They're in between. Notice that on the periodic table, they're located in between the metals and nonmetals. So it makes sense. There is some trend to the periodic table. All right, and we like to call this trend here for the metals and nonmetals the staircase. Staircase lets you know where the metalloids are. As we said, metalloid properties have both metal and nonmetal characteristics to them. So something like silicon or germanium, though shiny in that, are actually fairly brittle if you hit them. So even though they're shiny like metals, they kind of can crumble like a nonmetal. So they're very in between. Looking further on the periodic table, to dissect it to understand it a little better, on the periodic table there are horizontal rows. Those horizontal rows we call the periods. And on the periodic table there's groups or families. Those are the vertical columns on the periodic table. So we have periods and groups or families. Let's look into those a little further and see if they have any names. If you look, each group or family is designated with a number. This number is not only for reference, all right, but you're going to see that if you are in the same column or the group or family, you are going to have similar traits to the one above or below you. For example, here are the metals. If you are in group 1 on the periodic table, you are considered the alkali metals. If you are in group 2 on the periodic table, you are considered alkaline earth metals. If you are in the groups 3 through 12, this whole area is considered the transition metals. All of these are names given to the families because they have similar properties. As for nonmetals, the two main families I want to talk about is the second to last group, group 17 right here. These are called the halogens. And then the very last group, group 18, or sometimes it's called group 0. These are called the noble gases, and they tend not to react with much. And when we get into chemical reactions, we'll see why noble gases usually aren't much of a part of it. So here we have all of our different family names written down. Nonmetals, you have the halogens, you have the noble gases, the transition metals, the alkaline earth metals, and also the alkali metals. Two other groups we didn't mention are on the bottom here. If you notice that they kind of take themselves out of the periodic table and go on the side. But those are the lanthanides and the actinides, which we'll use more when we go into nuclear chemistry. If you didn't take out those lanthanides and actinides, the periodic table would actually be quite a bit longer, because instead of taking these guys out, we put them back in. So it is amazing that once we take this out, our periodic table actually becomes very nice and fairly concise. The reason it's called a periodic table is because if you ever had like a magazine that's called a periodical or that, it comes at a reoccurring time frame. So this table of elements is actually full of different trends that we can learn about that can help us understand more about elements. But more for that later. Take care, thanks for listening, and have a great day.